Hi everyone. Today, actually, I'm going to start doing a series of presentations and lectures for my students and my colleagues, because I have been asked to do these kind of things since long, but actually I was having no times, and I still don't have time, but I will manage my time to do it because it is necessary to do it for them. Um, this kind of series actually it will be covering the petrophysics, formation evaluations, and the later when I have time, I will do some part of reservoir engineering. Um, so I will actually try to make two versions, one in Arabic and one in English. So I will start with English one, and it will be posted on my YouTube channel, which is already there since long. I've posted many things there already before. So to do this kind of petrophysical analysis formation evaluations, you have to start with the tools itself, and after that, the interpretation techniques and the integrations. To start with the logging tools, I will start with a basic one up till to finish with the advanced ones. So we'll start from gamma ray to the very high technology tools and high technology techniques and all these kind of things. The beauty in these presentations, it will be not too long and not too short, just 20 slides max. It will be finished maybe within 20 minutes or maximum half an hour. And also it's not only academics, it will be covering many aspects from all industries since I was 25 years in industries, work worldwide in the Gulf and Asia and Egypt. With big companies which already have their own tools and all techniques. So I will be happy to transfer this kind of knowledge to my colleagues and my students. Um, the whole idea from this presentation is actually just to share knowledge to the others and nothing to do else. So let's start with one of the tools which is already always you found it in any logging in Ibn hole, cased hole, LWD, whatever it is, because this is mandatory to run this kind of log in the in logging programs, which is actually is gamma ray logs, which is actually is called gamma ray logs. So today it will be covering the gamma ray principle, the basics of gamma ray uses, why we use the gamma ray. Touch spectral gamma ray because we have two type of gamma rays like total gamma ray and spectral gamma ray. Gamma ray parameters. What is the limitation for the gamma ray? Gamma ray for unconventional resources. Gamma ray normalizations. Why you're doing the normalizations? And also, I will try to do some sort of comparison between the gamma ray and ECS interpretations. How we use the gamma ray to calculate the volume of shale. This is very famous calculations. Everybody in industry he knows to calculate the gamma ray from the volume of shell from gamma ray and how to use a gamma ray to recognize the position environments and how to use a gamma ray to differentiate the clay typing and the clay and the shell distribution in the reservoir rock itself. And we'll come back to the conclusions about that. The gamma ray principles. So everybody knows in any rock it has some radioactive source. The main contribution for the gamma ray measurement in the Earth is actually the potassium and the uranium and the thorium. Each one has actually his specific energy. So let us go to the result point. You see here actually this kind of thorium and the uranium and the potassium. And the sum of these three of them, you will get actually the energy for the total the gamma ray in this case. Um, so this is very simple to know it. So the gamma ray, it's come from the three main sources, potassium, uranium, and thorium. Later on, by using a spectral gamma ray, we'll explain which one elements in the Earth it will contribute to the shale and the one it is not. So what is the basic gamma ray uses? Actually, gamma ray can be used in many applications and many uses. We can use actually for the shalness, how to know the shalness. That means if you have like a shale or not shale. But they have to be very careful when using the gamma ray to identify the shale. You have to use actually the environmental corrected gamma ray, which is actually related to the potassium and the thorium, not related to the uranium. Can use it actually for the coloration also. If you can see, this is some specific well here, and you can see the colorate from this zone to this zone up to this zone. That means the gamma ray can be used as a good tool for colorations, and you see actually the how much is the horizontal extensions from the rock inside the formations by using this kind of markers and the correlations from this one. Also, sometimes use it for sub-sequence logging. That means in Holland, for example, use a gamma ray actually to see the movement of the surfaces by logging before and after, and the difference between them. You can see how much the subsidence depth has been shifted during the movement in the sea like that. For the gamma ray tracers, they sometimes inject some radioactive source in the formation and try to monitor by gamma ray to see how much is the safe zone and stuff like that on the casing. For the clay typings and deposition environment, will later coming slides, I will show you how exactly can a gamma ray, spectral gamma ray specifically, which actually would use the sodium and the potassium, use it to identify the clay type. Is actually this kind of cross plot here. I will explain it later on about it in coming slides to see from the potassium and sodium value ratio. You will see locate which type of clay type like lights or micas or mixed layers, all this kind of glauconite, whatever it is. And from the ocean environment, also from the shape of the gamma ray, later on you will see if which kind of environments like delta, fluvial, tidal, whatever in this marine, offshore, all this kind of environments for that. So spectral gamma ray, when you say spectral gamma ray, guys, you have to actually know there is a differences. In the total gamma ray, this actually, it is the gamma ray, like a gamma ray lump of sum, like a gamma ray curve, like that, like gamma ray curves, which is hidden inside it. Is it come like a sum of sodium, potassium, uranium, and you find it like that. But spectral gamma ray, it is actually give you the three different measurements for the uranium and the sodium and the potassium as a separate measurement. And we can use each one of them as a different indications. For example, like uranium, in this case, we can use it actually as an indication for organic matters and stillates for some specific formations. Sodium, if you have access of the sodium, indicates the clay content. And each sodium value and the potassium value, according to the ratio, we'll show later to give you the clay tapping from the cross plot. I have seen you before, but I will go deep in it for upcoming slides. This is one example actually showing you the spectral gamma ray. If you can see here, this is the gamma ray value, and here actually is the CGR value between both, and you can see the separation between both of them. It is like the uranium effect in this case, which actually indication for the source rock. Actually, this example from the Gulf area, and this formation is plastics, and it has some rock eval analysis in terms of 2C and VR and all this kind of S1, S2, which indicate actually this is a source rock of this reservoir. And if you can see here, this is the NMR tools. NMR tool is actually, this is a TT distribution and this is the TT cutoff. You can see here actually kind of T distributions is already before the cutoff. That means this is not a free float. It's already it's not a free float, but still rely in the some sort of rock. That means it has some hydrocarbon, and but it's not movable. Maybe some tar on it like that, and and this is actually translated from the uranium from coming from SGR, and there's a high resistivity value in this case. The applications for the gamma ray in carbonates and the ACS tool. Actually, I bring the ACS tool here later on. I will make a specific presentation for ACS tool. ACS tool is like an elemental capture spectroscopy tools, and it's kind of gamma ray tools, sorry, kind of neutron tools, and we can get the gamma ray later on from it to produce this kind of elements in terms of silicon, calcium, um, sulfur, iron, all these kind of things. But what I'm showing here actually in this specific slides, this is actually the calcite, which is actually the blue stuff, and this is the gamma ray here. You can see the high gamma ray, which is actually due to the radioactive source, not the shaleness. That means if you run actually the normal gamma ray here, which is give you the lump sum of the total gamma ray, it will not help to identify the volume of clay in this case. But if you have spectral gamma ray, it might be help in this case. So that means the gamma ray is not anymore indication for the shell and for the shell, but indication for the active source in this case. For the gamma ray plastics in the sandstone, actually, we have sodium indicates what clay contains, and the heavy mineral will show the heavy mineral example. For potassium, indicate for mica and feldspars. In the shale, as we mentioned, uranium suggests source rock. Like we have like some sort of high uranium, and you are in the clastic sandstone stuff. That means you might have some sort of source rock. But in this case, I would say don't look for one curve in the interpretation. You have to look to resistivity. You should have in this case the high resistivity log, because when you have a source rock, you should have high actually resistivity value. And this is some application for that in the unconventional reservoir analysis later on. I will do a lecture for that. And as mentioned, the K feldspar indicate for the clay type and the mica. This is just example showing the clastic environments, which actually here is like separation between CGR and HGR, and this is actually the sodium potassium values here. And just as example here to show you how looks like the how it looks like the clastic formation. We see a gamma ray like that, which is for the shell, and you see low gamma ray in this case indication for the sand, and this is dense neutron separation, so it's indication for the gas, and this is high resistivity tool in this case. This example actually from Kuwait. I presented in GU 2004 in one of the presentations there, and you can see here the gamma ray in the clastics when you have like hot sand, feldspar in this case mica, is not indication for the shale, and you have to be careful in this case to see the shaleness in this case. In this case, actually, if you are using the gamma ray alone and run it and to get an indication for the volume of shale, that means you will actually miss this formation in this case. And we are the luxury of running the ACS tools and the FMI tool in this case, which confirm this kind of formation. It is already sandstone and have very minor clay content and have some sort of indications from the FMI, use like a cross peeling from FMI also in this case. Indications not any more of this shale indication from the gamma ray. This is another example from Kuwait as well, which indication actually high gamma ray also, but is not related to the shale. The lesson learning from this one, actually, be honest, you have to know the environment. If you have like this kind of feldspar, that means for sure you have to run a spectral gamma ray, not the normal gamma ray in this case, if you need to get clue about how much sodium potassium, how much is the clay type in this case, and how much is the volume of shale in this kind of reservoir. This is gamma ray actually, and again, it's a plastic. If you can see here, in this specific file, which is actually sideриtes coming from the S0 of an axis of iron. And you see high gamma ray in this case. Also, you might also see this is very shaly reservoirs, but it is not actually. It is related to the uh, high minerals, which is actually sideриtes. So so better again when you use a gamma ray to get the shale to think about it to try to integrate it with the other log in this case. This example for the gamma ray indication for the shale. Uh, Sorry, indication for the cool. You see that when you have a cool, actually, it is very obvious from the density neutron. You have very low density, high neutrons, but you will have, and I actually also resistivity, but you will have actually very clean. This actually kind of peak here is very clean gamma ray. So gamma ray can be indication for the cool also and the environment for this kind of analysis in this case. So in this case, we know it is already related to the coal. For the gamma ray parameters, each tool actually have to know what is the investigations, what is the vertical resolutions, what is the role of sum of measurement of the value for the gamma ray and the reservoir rocks in terms of limestone, dolomite, sandstone. Shale is, it's variable, so you don't have a fixed value for the gamma ray in the shale from country to country. From experience, it's different. In Kuwait was have different value. In Malaysia, have different value. In Aramco has different values. In Abu Dhabi, I have worked all this country, but it depends the value from the gamma ray value from country to country and the type of shale and the environment of the operation environment for each countries. What I need from you actually to know from this slide to see the vertical relations for the gamma ray and depth investigation in this case. And here you can see roughly how much vertical resolution and depth investigation for one specific core in this case. Each tool actually it has some sort of limitations. The gamma ray limitations, when I say limitation, means there is some factor affect the tool measurements due to the borehole itself in the drilling fluids or due to some specific value in the reservoir rock itself. For example, the gamma ray, if you have like organic matter, it will be actually give you high gamma ray, but it's not indication for the shale, as I mentioned, indication for the source rock in this case. For spectral gamma ray, if you have evaporate in the mud, this will be reduce the count rates, but can be partially corrected, can actually corrected in the software, the TechLog or other software in this case. When you see actually KCl in the mud, in this case, you see how much the potassium in the mud, it will be affected the total count rate in this case for the gamma ray value, so it has to be corrected in this scale as well. You have also large borehole, you see the bit size caliber and see how much difference between both. It will decrease the count rate in this case, so it gives some error. This is actually present is just one example for the tool strengths which you combine it to each other. You can see the gamma ray in the top. This is the neutron. This is actually the TLD. There's a MSC field, which is like a density log, and there is some resistivity log in the bottom section. In this case, like that. Just example to see how it looks like during the rolling of the borehole. In this case, it maybe looks like a PIX. In this case, called PIX in Schlumberger. Okay, for gamma ray for unconventional, I have presented this before. For unconventionals, this is a big story, so later I will make one presentation to cover this. But now we're dealing this from specifically gamma ray standalone. So gamma ray, as I mentioned to you, if you have a like uranium, high uranium effect in this case, that means that already you have some sort of source rock, and this actually star score or corrosion. And as I mentioned to you, it will be in the NMR itself, it will be before the cutoff curve in this case, and have high also resistivity in this case. This is for source rock from uranium as a conventional resource in this case. Sometimes also have also something is called a low resistivity bay or seam bead analysis. So that means it will coming from upcoming slides. It depends how much is the sort of shale interbedded or located in the rock itself, if it's dispersed or laminar or whatever like that. So can be used the gamma ray curve itself with little porosity or dense slope, and by using the Thomas Taber techniques for this kind of cross block, and you can see if this kind of shale is eliminated when you see all the data cloud put it here, or you see the cloud put it here, it should be like a dispersed. That means gamma ray can be used also to identify some unconventional resources and low bear reservoir as well. The clay distributions inside the formation using gamma ray and porosity. You see how much what is about the clay typing inside the formation. Why the clay typing is very important? Because each one actually of them has a specific parameter or properties to be used in ELAN later on, such as cationic exchange capacity and this kind of CEC values and all this kind of things. So it's better to know lights or mixoglide or gluconite or whatever it is, because when you select in the ELAN or whatever in analysis this kind of inputs, the software itself has some database to use proper value for each kind of claims analysis itself rather than to put it in hand. Okay. Gamma ray normalizations. What's gamma normalization? So many people actually you hear about this kind of normalizations. Not even for gamma ray, maybe for neutron, maybe for BEF, maybe for density. Well, I've done many work in the big project in Aramco. I've done big project in Aramco for Gawar or Upcake or Underfields. I've done for Dukhan field in Qatar. I've done a lot of work in Malaysia in terms of this. And in big project, actually, sometimes you have to do some sort of normalizations. And we don't know a gamma normalization because we are talking about gamma ray also. If we're talking about the density neutron or some normalization. But why you are doing normalizations? Why that? Sometimes in big field which have like more than 5,000 well or 400 wells or this kind of big projects. There's too many companies. Sometimes you have some in the same specific field, some people doing some sort of running the tools, and that means you have different vendors to run in the different boreholes for the same formations. Yeah. And have some people do some corrections, some people doesn't have some corrections. That's why we do this kind of normalizations, because we need to get standardized values for the same layer in the whole field with this specific value. For example, for volume of shale, we have to get a minimum and maximum value. If we need to do volume of shale for some specific wells in some certain areas, so we have to get some standard, because sometimes people do some things called the multi-well analysis, multi-well ENAN. You have like 6 wells or 10 wells at the same times, and you have to do some specific value for the gamma ray to get a minimum value. To do that, you have to use this kind of normalizations to make it all of them is right. So what you have to do is you select keywords, some keywords, good corrected data. If you have some code to see how much is the gamma ray values in this also this, and try to match this kind of thing to fix these values. Later on, if you have some sort of wells already deviate from this kind of values, so you have to bring it back by normalize it together to get some sort of something like that. Well, that means the gamma ray for this well, all of them has been normalized, and you can be used later on to do the analysis. Very important also step for normalizations, because some people also do some things called facial analysis. Facial analysis sometimes in IPSOM use some specific curve like gamma ray, density, neutron. For sure should be gas corrected, and the Samsonic also gas corrected, and also use gamma ray. So in this case, gamma ray sometimes in some certain field have some values, and some certain wells have different values, so it will some deviation from that. That's why we have to normalize it to represent this information horizontally and all the field in this case. So this one a good step to do this kind of normalizations for this kind of fuel. It will be better to do that. Okay, so gamma ray and radiation environment. So our geologists actually they use, especially in the clastic formations, they use the gamma ray shape to identify the deposition environment. This is actually here. This is all deposition environment, like a cartoon showing all deposition environment here. And This is just one example for the coursing up gamma ray in sequence like that. And this is the most famous shapes from the gamma ray sides when you found it to identify the environment. For example, you have like a pill, you have a funnel, you have cylindrical blocky, you have actually concentric which looks like something like zigzag like that. So whenever you have a bill like bill shape like a bill shape, this may be channel sand or coastal plain environments. If you have like a funnel, maybe this is delta beach sand or mouse bar stuff like that, or shallow marine. If you have like cylinder block stuff like that, like global channels or something like basin floor frame like that. And this also for slope fan. Each one of these actually here, it is already here and more detailed about it here. So you can see each one of these, you see the kind of environment in this case. That means from gamma ray itself, you can see actually to see the environment which are dealing about. For example, this kind of coursing up in this case, which is like in this case, you will see something is actually related to the delta environment, delta or the delta environment in this case. So in this case, one like that. The delta actually, it's something between the river and the and the sea, and you can see this kind of like private, like in Egypt, like Nile Delta, and definitely delta all over the world in this case. So the whole idea from this exercise is we're using the gamma ray shape to identify the position environments. Finish this by 30 minutes. This is the gamma ray volume of shale. Actually, very famous. Everybody uses the gamma ray actually to calculate the volume of shale. But as I mentioned before, be careful. Bear in mind, you have to use the gamma ray which is related to the sodium potassium. It's called KTH in Baker. It's called decision on Schlumberger, like that. So you have to use this to kind of gamma ray to present the volume of clay. So the volume of shale actually here in this is called gamma ray log, nice gamma ray minimum, gamma ray maximum, not gamma ray minimum, Schlumberger equations. Gamma ray minimum maximum, you can get a sick clean shale, you get the maximum value, and you go to clean shale, get the minimum value, and apply it here. It's actually called V-shale index. You call V-shale index. So some people actually use this later on after some clever equations, and this is how to present it by using the index to calculate the clevers and the Stieber's Thomas Stieber's equation to do that. Some people calculate all of them, and at the end of the day, take a final shell calculation. You can get arithmetic mean or whatever averaging methods to represent the volume of shale in the reservoir like that. And this is a real example. We use actually the gamma ray, V-shell from gamma ray, and V-shell clever Stieber, and you can get actually the final here, make arithmetic mean between all of them like that. Okay, core gamma ray. Also, some people you hear about the exhibition is called core gamma. Core gamma means whenever you get the core from the field and you go to the lab, they put it actually here inside this kind of measurements, measurement to get the gamma ray core data, and you measure and you record this kind of thing. So why is this important? Because sometimes we need to after that to shift the core to the logs, because what later on we take this kind of core measurement to take some small core later on also make also another implementation for the core analysis and the measurement in the scale and the routine, both of them. So we have to know actually when this core has been located, which depths, because we're doing the porosity permeability measurement. So I have to use this kind of core gamma to do log depth shift with the will log later on. You can see here actually this one of them, the core measurement and the log measurement, and you can see both of them quite match between them. And if you have like a mismatch, always you shift to the core to the log. You always shift to the core to the log, not opposite way. And if you have LWD also, you shift the LWD to the wireline logs. Okay, wireline logs always the base better for you. So the whole idea here from me is what I need to say here. You have actually core gamma measurements. You have to take it and try to correlate it with wireline logs and try to shift it to get the better match between them. But later on, you have to shift the porosity and permeability, the saturation coming from the scale analysis from the log in this case. Okay, the gamma ray corrections. So the gamma ray corrections, the measurement has to be corrected. I mean, when you do the tools, when you manufacture the tools, it have some standard conditions. in the lab on the workshop. Once you take these logs and you go to the field, the environment may be not the same like the workshop or calibrated. So you have to do some correction in terms of specific borehole site, in terms of mud weight, in terms of pyrite, in terms of the casing. All this kind of correction has to be done. So these two charts here in the this chart in correct for actually the gamma ray in terms of borehole and stuff like that. And this actually also the gamma ray for the mud if you have a barite in the mud, and this one actually for the casing. This is actually very experimental example. You can find it in the Schlumberger book or even Halliburton book or even Baker book. All this kind of analysis is very detailed there. It will be easy to get this kind of corrections for the gamma ray. And this is actually nowadays done very easy by using the tick log or even in IB, whatever, in other softwares. But make sure when you do this kind of corrections, you have to go to the field print to see which kind of correction has been done from the field engineers. And you go to your software to do the corrections to ignore the double corrections has been there. This is not only for gamma ray, for all the other tools, especially for neutrons, because neutron has like more than 12 corrections. Later on, we'll talk about it later. That. Okay, this is actually the gamma corrections. So also to you get something out of that, and I hope I add some value to you, and appreciate you following this all this kind of presentation which I'm going to present and post it in my YouTube channel in that. And appreciate your timing, and I hope I add value to you guys in this case. I might also do some Arabic version for that. I will see about that, but I will do inshallah about that. Thanks a lot, and goodbye. This could be posted on my YouTube channel, so we can actually use this kind of channel